Welcome to the first video in our data structures and algorithms series. In this series, we'll be going through different data structures and algorithms by diving into Leetcode problems and understanding the core concepts. Problems are selected from Neetcode's roadmap, which you can check out on his website. Link is mentioned in the description below. Neetcode's roadmap includes the famous 75 blind questions along with 75 of his own selected questions, and I think they're the best way to get started with DSA. So now let's get started with this video. The first topic we will cover is arrays and hashing. It will be covered in two videos. This is the first video where we will briefly go through the data structures we'll be using for this topic, followed by solving 4 Leetcode problems, 3 easy level and 1 medium. In the next video, we'll cover 4 medium problems on this same topic. I've added a link in the video description to learn about time and space complexity as a complete beginner. Make sure to see that before moving forward with the series. So, what are the data structures we'll be using in this topic? They are arrays, hash sets, and hash maps. So what exactly are they and when do we use them? Arrays and lists are a collection of elements that are stored adjacent to each other. Each element has an index which makes it easy to access and manipulate data. Thus, the order in which elements are arranged matters when we use arrays. So you would use arrays when you have a collection of items that you want to keep together. Arrays are particularly efficient when you need fast access to a particular element, but remember that their size is fixed in certain programming languages, so they're not the best choice if you need to frequently insert or remove elements. This is the time complexity to do various operations with lists. Moving on to our next data structure, we have hash sets or sets. These data structures are used when you want to store a collection of unique elements. A set, or more specifically a hash set, ensures that you don't have any duplicate values. It uses a hash function to map each element to a unique location within the set. You would use sets when you need to work with a collection of items, but you only care about the unique ones. Think of it like a list of your favorite movies. You don't want to see duplicates in it. This is the time complexity to do various operations with sets. Lastly, let's talk about hash maps, also known as dictionaries in Python. These are the key value pairs where each value is associated with a unique key. Hash maps are used when you want to map one piece of data to another. For example, you might use a hash map to store a list of people and their ages. Here, the names are the keys and the ages are the values. They're kind of like objects in JavaScript. This is the time complexity to do various operations with hash maps. So now that we have a good basic understanding of these data structures, let's dive into the Leetcode problems. So the first problem we're going to solve is Leetcode 217 contains duplicate. In this problem, we are given an integer array nums and we want to return true if any value appears at least twice in the array. And we want to return false if every element is distinct. So for example, we are given nums equal to 1, 2, 3, 1. And the output is true because the element 1 appears at least twice in the array. It can be more than twice, but in our case, there are 2 1s appearing in our list. In example 2, every element is unique, 1, 2, 3, 4, and thus it returns false. In example 3, however, there are multiple elements having more than 2 occurrences in the entire list. And that's why we return true. So this is the problem that we want to do. I recommend you to pause the video and try it on your own and see if you can do it. If you can, just see the solution and move to the next problem. If not, no worries. You can understand the explanation, then try to code it on your own. So let's move to the explanation now. So first of all, let's open up our whiteboard and draw here. We have the element array 1, 2, 3, 1. So this is my array. Now what I want to do over here is basically find similar elements in this entire list. So what I can do is iterate over all of these elements. So I'll go over 1, 2, 3, 1 and then check it with the remaining elements in the list. For example, if I'm on 1, in my first loop, I'll just go over 1 and then I'll check for the remaining elements in this list. Okay, so I'll compare. Is 1 equal to 2? Is 1 equal to 3? Is 1 equal to 1? And then I find my answer. That's pretty straightforward. But what if instead of 1, the element was 3? Alright, let's consider the element over here was 3. So we checked 1 is equal to 2, that wasn't correct. 1 is equal to 3, that wasn't correct. 1 is equal to 3 again, that wasn't correct. So what we do is move our iteration from 1 to 2. Okay, now we are at 2 and then we're going to check if 2 is equal to 1, if 2 is equal to 3, if 2 is equal to 3 again. That isn't the case, so we move to 3 again. Then we check if 3 is equal to 1, 3 is equal to 2, and 3 is equal to 3. Finally, we get our answer and then we return true. If none of the elements match, for example, we have 4 over here, then it will just go over 4 as well and check if 4 is equal to 1, 4 is equal to 2, or 4 is equal to 3, and then it will return false because the loop is ended. We didn't return true even once. That means there's no element for us in the entire list. So this is the first approach, the straightforward approach I can think of. And it is correct. We can do that. But the problem with that approach is the time complexity of it. I have to iterate over all of the elements first so that I get access to each element so that I can compare the remaining elements with them. And then I have to grab the remaining elements again and iterate over them. So I have to run 2 for loops that are within each other. So the time complexity for this would become O of n square, where n is the length of the list. Because first I have to iterate over all of the elements so that I grab an element I can compare another elements with, and then I want to grab the remaining elements in the list. Okay? So I have to iterate over n elements every single time. So that's O of n square, and we know that's pretty bad. The question is, can we do better? Can we improve our solution? So the problem with our solution was that we were going over every element twice. So if we were at 1, we again went through 1 all the way till the end of the list. If we were at 2, we went over 1 till 3 again. So that was the problem. We're going over our elements twice in the same list. And if we're creating a solution that has duplicated work, we know that the time complexity can be reduced. So I need to figure out a way such that I go over all the elements only once and then I get to know that they're already there in the list. So what can we do? So I think I have a solution so that we only go through once and figure out if the element is already there or not. So what I can do is create another array over here, and then I'll say, hey, does this element that we are iterating over exist in the array already? If it exists, then we have found the duplicate. If it doesn't exist, then I'll just add that in the list. Then I can go over 2. Does 2 already exist? No, I'll add it to the list. Does 3 already exist? No, I'll add it to the list. And then I'll say, does 3 exist in the list? Yup, it does. So we'll just return true that the element exists. Instead of 3, if we had 4, it would stay 4 in the list. Our iteration is over and we still haven't returned. So that means there is no duplicate element in our list. And that means we'll return false. But the problem with this approach is it will again be O of n square, plus it will also take a memory of O of n. And that's because we are creating an extra array which has n elements in it. So the extra space would be O of n, but the time complexity would also be O of n square because we are iterating over this list. Then we'll again iterate over this list to check if the element already exists or not. So that is a worse solution in comparison, but we at least have an algorithm such that we know we only have to iterate once. So instead of using an array, what can we use? To understand that, we need to understand the problem with this. So the problem with the solution was I iterated over all of the elements. That was necessary because how else would I know if there's any other element in the list? So O of n is fine, but O of n square isn't, and we have n square. That means the another n is there because of this thing. We had to iterate over all of the elements to know if there was already an element in it. So can we have a data structure where the lookup time isn't O of n. The lookup time is O of 1. And we have a data structure for that, and that is hash set. So we can just use a hash set and store elements in it. And if we have an element in it, we'll just return true. Otherwise, we're going to return false. So to demonstrate a clear solution for it, let's say we have a more complex example. Let's just copy this. So what we're going to do is we're going to create a hash set. Okay, we have our hash set created. And now I'll iterate over all the elements and see, is 1 already present in the hash set? No. So we can add that in the hash set. Is 1 already present in the hash set? There we go. It will return true. So I think this was a pretty easy one. Let's take a more complex example. We can just take this array and see if that works. So here I'll again create a hash set. And then I'll check if 1 is already present in the list. It is not. So I'll just add 1 over here. Is 2 already present in the hash set? No. I'll add it again. Is 3 present in the hash set? No. I'll add it again. Is 1 already present in the hash set? Yep. So it will return true. And in case of 1, if there was 4, then what would happen? Well, we would go over all of these solutions, let's say. So we have 1, 2, and 3 done. Then I'll go over 4. 4 is also not there, so it will be stored in the hash set. And now it will just return false because all of our elements are exhausted in this list and we still haven't found a result that is correct. So that means we're going to return false. So the time complexity for this would be O of n because we are iterating over the list only once. And the space complexity for this would be O of n as well, because we are creating a hash set and storing n elements in it. In the worst case, obviously. In 1, 2, 3, 4, in our worst case, we had no elements similar, so we stored all of them in the hash set. So it was O of n as space complexity as well. So let's code it up and see what the solution looks like. We are given that the type of nums over here is list of int and the return type is boolean. So we need to return a boolean. That's pretty helpful. So what we need to do first is create a hash set. So if you're using Python, you can create a hash set pretty easily. So you can just create a hash set, which is like this. Obviously, you would need better naming. I'm just keeping it hash set. You can name it something else. Now what I'll do is go over all the element in nums array. I'll iterate over this entire list now. So what I can do is for n in nums. So that's how you do it in Python. If you're using another programming language, you can use that for loop. We're basically iterating over all of the elements in the list. And now I'm just checking if n is in hash set. So this is how you check if the element is already present in hash set or not. So if the element is already present in the hash set, we'll return true. Otherwise, we can just add it to the hash set. So we can just do hash set dot add n. So if the number we are currently iterating over, which is 1, 2, 3, if they are already present in the hash set, we'll return true. Otherwise, we can just add it to the hash set, and what we're going to add is just the number. And that's basically it. Now, if the iteration over all of the elements is complete and we still haven't returned true, that means all of the elements are unique, just like this. So we'll return false over here. And that's our code. If we run it, it is accepted and we can submit it. And we have our accepted and yeah, it looks good. So this was the solution and the basic usage of hash set. Now let's close this and move on to another question. So the next problem we're going to solve is Leetcode 242 valid anagram. So we're given two strings s and t and we want to return true if t is an anagram of s and false otherwise. So what is an anagram? Here it's given an anagram is a word or a phrase formed by rearranging the letters of different word or phrase, typically using all the original letters exactly once. So for example, if S is anagram and T is Nagram, it will return true. Why? Because if we rearrange Anagram with Nagram, it can happen. So let's just say if we have Anagram over here and we have Nagram, how will this rearrange? Well, if I just put N in the middle, then I put G over here and A over here, we have it. So I didn't have to add any other letter. I didn't have to add any other word, obviously. I just reuse the letters, I rearrange them, and I get a new word. So that's the basic point of an anagram. If we see rat and car, they are not anagrams, so it returns false. Because we have R over here, there's R in this T as well. Then we have A over here, A is present in T as well. But when we search for the character T in the string T, there isn't any T in the string T, if that makes sense. Or if it gets confusing, C is present in string T, but C is not present in string S. That's why they're not anagrams. Basically, the same letters were not there, because of which they didn't become anagrams. So we have basically reframed our question to think differently. We're now saying that, hey, I just need to compare if all the elements are same in S and T. So let's see. Can we do it? Let's open up our canvas. We'll do a free draw. And let's put this example over here. So my straightforward approach, my brute force way says that, hey, iterate over all the elements in S, go over all of them, then check if A is present in all of these letters. If it is not present, then we'll return false. But if it is present, then we'll just keep on iterating. Then we'll just move to N. And for N, we'll check if N is present in all of them. If N is present, I'll again check for A. So now the problem comes in. I'm checking for A again, and A is already there. But there are two A's, right? Actually 3 A's, right? So we have already checked that one A is there. We have already checked one N is there. But again, when we come to the second A in our string S, we are again checking the same A. So we are checking if A is already there. That means if we had a string like N, G, A, R, M, it would return true for this as well. Because I'm iterating over all of the elements, so I'm going over A and checking if A is already there. Yeah, A is present. Then I'm going over N, N is already present. Then I'm going over A again, and then I'm checking if A is present, and A is present. Because A is over here. We have not removed this A from our string, it's still present. But this isn't an anagram, because if there are 3 A's in our system, we want 3 A's present in another string as well. So this was the problem, and this is why we cannot use this part. Obviously, we can remove a character from a string, but that isn't a nice solution. It isn't a nice solution because it can take a time complexity of O of n to remove the string or to remove a character from a string. So what can we do? Can we use a hash set that we learned in the previous problem? What we'll do is we'll just create a hash set and we'll store A over here, N over here, A over here, G over here, R over here, A and M as well. So we'll store all of these characters in our hash set, and we'll similarly create another hash set for this as well. And then we'll check if both the hash sets are equal to each other. If both the hash sets are equal to each other, that means they're anagrams of each other, otherwise they're not. And the problem with this solution is hash set have a property wherein they can't store duplicates. So if A is there, I store it over here, N is there, I store it over here. If I try to store A again, it won't store another A because A is already present in the hash set. So hash set cannot store duplicate elements or duplicate characters. So this method is not feasible as well. What can we do instead? Another approach that might not be so intuitive is basically just sorting the string. If we just sort this string and this string, what will happen? Well, A will come over here, A will come again, A will come again, then it will become, I guess, G, then we have M, then we have N, and then we have R. Okay? This would be the sorted string for S. And what would be the sorted string for T? It would be the same thing. We have A first, A second, A third, then we'll have G, then we'll have M, N, R. You see? So we'll sort both the strings and then we'll equate both the strings and see if they're equal. And yep, this solution works and it's pretty nice solution, but the problem with this is we have gone from a time complexity of O of n square to O of n log n, because sorting takes a time complexity of O of n log n. So what is the next solution we can take? Well, what is it that we want to do in this question? We basically want to check if the characters are equal or not. So if there are A's, there are same amount of A's in both the string or not. If there are N, there are same amount of N's or not. If there is a G, there is the same amount of G. If there is an R, there's the same amount of R, and the same goes for M. So we basically want to check how many characters there are in each of the string. So if there's A, there are 3A in the string S, there's 3A in string T, there's 1N in string S, 1N in string T, 1G, 1R, and 1M in string S and T. And that's why they're equal. So what we can do over here is basically create something known as a hash map. So what this hash map will do is it will store a key value pair. In some languages it is also known as a dictionary, including Python. And here we are going to have the key as the character and the value as how many times the character appeared in a particular string. So we're going to create one hash map for string S, one hash map for string T. Okay? And then we'll iterate over all of the elements and store it in the particular dictionary. So let me show you a dry run. What I'm going to do is I'm going to erase it from here and I'm going to type it out here. So I'm going to have my string S dictionary over here. Okay. So first I'll store the A because I've come over here. We have A. So it is occurring one time. Then I'll move to N. So the N will also come in one time. Then I'll again move to A. But A is already present. So what I'm going to do is remove A1 and change it to A2. So whatever value A already has plus 1. Then I'll move to G. So the G is not already present. So I'll save it over here and save it to 1. Then I have R. R is also not present. So I'll just save it as 1 over here. Then we have A. A is already present. So we can increment 1 to it and save it as 3. Then we'll move to M and there we go. We have M saved as 1. So this is our dictionary or hash map for string S. We're going to do a similar thing for string T as well. We'll go over it and first we have N. Okay, so I have N stored over here. Then I'll mark the counter as 1. Then I'll move to A. So A will be stored over here as 1. Then I'll move to G. So I'll have G stored over here as 1 as well. Then I have A again. I'll increment A to 2 now. Then I'll go to R. R is not already present, so we'll have 1. Then I'll move to A again. So I'll have A incremented over here because I already have an A. And finally we'll have M. And I'll store it as 1. So we have a dictionary or a hash map created for string T. We have it created for string S as well. Now what I'm going to do is compare both of them. So to compare both of them, I'm going to iterate over all the elements of the hash map of S and see if the value is equal in both the cases or not. So if A is 3 I'll check if A is 3 over here as well. N is 1. I'll check if N is 1 over here as well. G is 1. G is 1 over here as well. R is 1 over here as well. M is 1 over here as well. So that way we get to know if both the anagrams are equal to each other or not. But the only problem comes in here is, what if this was NAG RAM and Z? Okay, so this was the string NAGA RAM Z. So that means when we are storing it in hash map, we have everything. So all of this is correct. But we also have a Z character over here stored as 1. So to check if the string S is an anagram of string T or vice versa, we're going over all the elements or all the keys of the string S hash map. And when we go through, everything is correct. The Z is, however, not included. So how can we check if Z is not already there? You might say, hey, we can just start from T, right? We can just loop over all the elements of T and check if they're equal to S or not. But the problem with that is, what if the Z was present over here and not over here? Okay. So that means Z comes over here and Z is not already present over here. So that's the problem we are facing, and that's an edge case. We need to figure out how to work with that. And the easy solution to that is basically checking the length of the string initially. We'll just check if length of string S is not equal to length of string T, we'll return false, because here the length is 1, 2, 3, 4, 5, 6, 7. And over here the length of the string is 1, 2, 3, 4, 5, 6, 7, 8. So they're not equal, so we'll return false. And if they are equal, that means Z is not there. And let's say instead of M we have Z. So that means Z over here is 1 and M is present over here, M is not present over here, so we'll just give it a value of 0. So M has a value of 1. Over here, M has a value of 0 or none or null. That means they're not valid anagrams. So I hope this explanation was clear. Now let's code it up. So we are given the types, string S and T are strings, and the return type is Boolean. What we're going to do is create two hash map. So we're going to create a map of S and we'll store it like this. In Python, you can create a hash map like this, or you can just create it like dictionary like this. Then I have map T, which is equal to an empty dictionary as well. So I've created two hash maps now. Now I need to iterate over the string S and store it in string map of S. So I have for character in S and I'll store it. So I have map at S. So map of S at. So using this, I can store it in the dictionary. So I'll have map at character equal to map character plus 1. So what I've done is I'm creating my dictionary. So initially A is equal to 1. A is not even existing, right? Here I'm saying, hey, go at A, see if there's a value already. The value is not already present. So just take the initial value. Now what is the initial value over here? The initial value is not there. And that's an edge case we need to figure out. If the character is not already present in my map S, and if I just use map S at character, it will give me an error. It will give me an error, and I'll just run it to show you that it indeed gives an error. You see, it says this because the map S at car, that means A, I'm calling map S at A doesn't already exist. And if it doesn't already exist, how am I calling that? So to make this work, what I can do is map S dot get character, comma 0. So what this does is it is a function that we call on the hash map, and then we say that, hey, get me the character. And if the character is not already present in the hash map, then just give me a 0. That's the initial value of this character. Okay? And then I can just increment it to 1. It will try to find A in the hash map. It's not already present, so it will take the 0 and then convert it to a 1. And then it will do that for rest of the elements. So it will do that for n as well, but for A, it will do map s.get A. A is already present over here now. The value is 1. So it will increment 1 by 1 again. So we'll have 2 now. And we're going to do the same thing for t as well. So we have for character in t, and then we're going to have map of t at character is equal to map t.get character 0 plus 1. And then I can iterate over all of the keys present in map s and check if the value is same for both of them. So we have for key in map t or map s, whatever you want. It will work either ways, and then we'll check if map underscore s at key. We can use this over here because we are iterating over all of the elements of map s only. So we know map s at key exists. It's not going to be none. It's not going to be any value we don't know. Map s at key is going to exist. And we're going to check if it is equal to map t dot get. Here we're going to use dot get because we're iterating over all of the elements or all of the keys of string s. There is a possibility that z is present over here and z is not present over here. That means map t at z would be called and map t at z is not present. So here we need to call character, okay? So it will try to get that character or the key, sorry. And if the key doesn't already exist, it will take the value as 0. If they both are equal, so there's nothing wrong with that. Yeah, go on looping and try to check if there's anything wrong. What would be wrong is if map s at key is not equal to map t at key. If it is not equal, that means both the values are different. That means they're not anagrams of each other and we can return false. Otherwise, we can return true over here. Basically, all of this happened. We did not find one single element that was of fault. So they're both anagrams of each other. Also, I forgot to put the if condition of checking the length. So if length s is not equal to length t, then we want to return false. So this is a very important edge case that we need to figure out. And if we do this, or actually if we don't do this, actually first let's just run and see if it works. It got accepted. If I submit, accepted. And if I don't do this, let's see if it gets accepted. It gets accepted over here, but when I submit over here, it gives me an error. 40 out of 42 test cases passed, and this is the problem that I was talking about. If we have a string A and we have AB, it returns true, but in fact it is false because it is looping over all of the keys of A, which is just A, and seeing if it is present in the string T. A was present in string T, so it returned true, but the fact is B is also present, so it is not an anagram of each other. So this is a very important edge case. So yeah, we are done with this question. I hope you understood this explanation as well. Now let's move on to the third question. So the next problem we are going to solve is Leetcode 1 to sum problem. We are given an array of integer nums and an integer target. We want to return indices of two numbers such that they add up to target. We may assume that each input would have exactly one solution and we may not use the same element twice. We can also return the answer in any order. So let's take a look at the example. We have input as nums is equal to 2, 7, 11, 15 and the target is 9. The output is 0, 1 and the output is 0, 1 because nums at 0, which is 2, and nums at 1, 7 they add up to become the target, which is 9. Similarly, in example 2, we have nums equal to 3, 2, 4. The target is 6 and the output is 1 and 2. The reason for that is nums at 1, which is 2, and nums at 2, which is 4, they add up to become target as 6. In the third example, we see nums is equal to 3, 3 and the target is 6. The output is 0, 1. It's not 0, 0 because we cannot use the same element twice, because 3 plus 3 is equal to 6. So I could just use 0 and 0, but here it's given that we may not use the same element twice. And we can also return the answer in any order. So that means instead of returning 1, 2 over here, I can return 2, 1 as well. The constraints are given, which is fine, but there's one constraint we need to keep in mind, and that is there's only one valid answer in here. So here we only have one valid answer. If we had, let's say, another element in our nums list, which was -2, then we would have two solutions, 2, 7 and 11, -2, right? Because both of them add up to become the target, which is 9. But easy for us, we only have one solution with us. So I recommend you to pause the video, try it on your own and see if you're able to do it. I'll move to the explanation now. So let's say we have elements here. We have 2, 7, then let's 11 and 15. What is the first approach we can think of? Well, the first approach I can think of is going through this entire list and iterating over each of the elements 2, 7, 11, 15. And then iterating over the remaining elements in the list again. So we have 7, 11, 15 for our first iteration. And then seeing if nums at I, let's call this I, and nums at j is equal to the target, which is 9. So how would that work? Well, we would just have 2 first. So we have 2 in our I. And then we'll go over the rest of the elements, which is 7. So 2 plus 7, 9. We got it. But let's say we had 11 here, we had 15 here, and we had 7 here. How would that work? Well, we would have 2 plus 11, 13. So 13 is not equal to 9. So we just move ahead. We have 2 plus 15, 17. That's not equal to 9. Move ahead. 2 plus 7 equal to 9. Yep, we'll just return the indices, and our indices would be I, j. Okay. So that is the first solution I can think of, and the time complexity for this would be O of n square because I'm iterating over each of the elements twice. And the space complexity would be O of 1, constant space, because I'm not using any external data structure. I'm just using the variables that were given over here as well. No data structure involved. So this is the thing, but can we do better? Can we do a better time complexity than this thing right over here? I think we can. And why do I say this? Because you see, we're going over the same elements twice. I'm going over 2, 7, 11, 15 twice. I don't have to go through them twice. So I'm doing some duplicated work. That means it can be optimized further. So let's think of another solution. Let's try to use some data structure, right? We know that there can only be one solution and we cannot use the same element twice. So that means we should be able to use a set, because we know the unique property of a set which says that, hey, you cannot have more than one element in my set. Okay, so let's try to use a set. We'll have a logic as we'll iterate over this list. Okay, and then we'll see if target minus the nums at I, let's call this iteration I. So I'll just see 9 minus 2 is equal to any element in the set. So that means I'll just check if target minus nums at I, that is 7, is present in the hash set. Is it? No. So just put 2 over here. Then we'll do the same for 7. 9 minus 7, 2. Does 2 exist in the hash set? Yeah, that's true. So we'll just return 2 from the set. And there we have our answer. What if our 7 was again present at the end of the list? Let's say 11 was present over here, 15 was present over here, and 7 was present over here. So we'll just have 9 minus 2. Is 7 present in the hash set? No, so I can store 2. 9 minus 11 minus 2. Minus 2 is not present in the list, so we'll put 11. We have 9 minus 15 minus 6, not present in the list, so I'll put 15. And then I have 9 minus 7. 2 is present in the list. Yup, so we can return true. But the thing is, we don't want to return true. We want to return the index. We don't have to return a Boolean value. We just have to return a list of integers. So that's where we cannot use a hash set. We want to return the index that was associated with this place. We had an index associated with all of them, right? So what else can we do? Well, we know a data structure that does exactly this. Let me just remove this. From what I said, what we needed was my hash set to point to an index, right? And whenever we say something like, hey, I want to point to this, we can obviously use a hash map. And in this hash map, my key would be the number and my index would be the value. So 2 would be 0, 11 would be 1, 15 would be 2, and 7 would be 3. So that's my hash map. 9 minus 2, 7. Does 7 exist in my hash map? No. So I'll just add 2 with its index. Then we have 9 minus 11. Minus 2, that doesn't exist. I'll add 11 with its index. Then I have 9 minus 15, the same thing. So we'll just pass in the index as 2. So we'll just have 9 minus 7, 2. Get it from the hash map and we'll get its index. So we'll have 0 and we'll also have 7, which was, let's say, 3, I guess. So we'll return that and we can return it in any order, so we don't have to worry about that. So I hope you understood the solution. The time complexity for this would be O of n, which is nice. And the space complexity would be O of n as well, because we're using a hash map. And in the worst case scenario, we'll have to store all our elements because let's say we don't have a solution. So we would store all the elements in the list. So n here is the length of the list. Okay. So now that we have understood this, let's dive into the code and type this out. The first thing we'll need is hash map. So let's just create it. And then I'm going to iterate over each of the element in nums, right? But am I going to use a for loop like this? No, because I don't want the access to just one element. I need access to the element along with its index. So what I can do is enumerate. In Python, you can just do this. And if you're using Java or something, you can just use like for int I is equal to 0, I is less than nums.length, I++. With Python, you can just do this. So initially, I'll get access to the index, and then I'll also get access to the current element. And then I can just create a variable which stores the difference. So what I need to do is take this target and subtract it from the current number we are on to find if that number is present in our hash map. So I can just have difference is equal to target minus nums at I, or I can just call it n, because enumerate gives me access to the particular element. And then I'll say if difference in hash map. So what this does is checks if any key matches our difference. So 9 minus 2 is 7. It will check if any key with 7 is present, and it is not present. So we are not going to do anything. But when we reach 7, 9 minus 7 is 2. 2 would be present in the hash map key. So we just want to return the value at 2. So we can just return a list where our first element is I, which is the current element, because if we are on 7, we'll return the 7th index. And then we want to return hash map at difference. And we don't have to do hash map.get difference. The reason for that is we've already checked if difference is in hash map. If difference is in hash map, then we definitely have a value. And if it is not there in hash map, then we can just add it to the hash map. So we'll have a hash map at n is equal to I. So hash map at 2 would be equal to 0. hash map at 7 would be 1, right? And then if none of these match, we can return an empty list, but I don't think this would ever come over here because I think there's always a solution. Now we can run this and see if it works, and it is accepted. And if I submit it, yep, accepted. So this was the optimal solution for toSum. I hope you understood why we didn't use set, we had to use hash map, and why the O of n squared solution could have been made better. Now we're going to dive into a medium Leetcode problem. So this is the problem we're solving, group anagrams, Leetcode 49. So we're given an array of strings, strs, group the anagrams together. We can return the answer in any order. An anagram is a word or a phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So it's kind of similar to the valid anagram question that we did earlier. And it's basically that we have eat, tea, tan, ate, nat, and bat. We want to place all the anagrams in one list. So we have eat, we have tea, and we have ate all in one list. And then we also have nat and tan in one list. And we have bat alone because there's no anagram of bat present in this list. In example 2, the list is an empty string, so we return a list of empty string. So it just contains an empty string because, well, there's no anagram. And the third example is a small letter A, and only that's present in this list as well. So this is what we want to do. We want to place all the anagrams of a word together. Now, I recommend you to pause the video and try this on your own. It is difficult, so if you're not able to do it, don't worry. You can continue with the explanation. So what I'm going to do is just take a screenshot of this and paste it over here so that we can analyze what we need to do together. Alright, so how do I know that what in this list is an anagram? So to know that, I take a look at each letter in a word and see, hey, E, A, and T. Are they same in any other thing? So we have TEA, this also is an anagram. TAN isn't. ATE is an anagram. And that's pretty much it. I get to know because I compare each letter in a word and see if they're equal or not. Then I also have tan, which is TAN. Then I compare other words and see even nat has TAN. And then finally I have bat, and bat is the sole word because the same letters aren't present in any other word. That's why we cannot use bat. So I hope you understand what we're doing. We basically need to keep track of all of these letters. And that's what we did in the valid anagram question as well. We kept track of all the letters and how many times they occur in a particular string, and we did that for both the strings and then checked if they're equal or not. We need to do similar thing, but more than just iterating over two strings. I need to iterate over this entire list to check if any of the word is an anagram. So we know we need to use a hash map over here. Our previous knowledge of the Leetcode solution tells us that. But how are we going to fit this in a hash map? Well, what I can do first is basically just sort this, right? So I'll have A, E, and T, right? And this will also be AET, and this will also be AET. So first, I'll just sort this entire list. I'll sort all the elements inside of this list. And then I'll just create a key over here which says AET, and the value will be a list of all the elements that have the same sorted string. So eat has the sorted string of AET, T has the sorted string of AET, and 8 has the sorted string of AET. So we'll add all these three over here. Okay, and we can do the same for the rest of the strings as well. We have TAN, so we can just sort this and put it over here. It will become ANT. This will also become ANT, and bat will be ABT, and there's no other string that is ABT, so we can just put bat as a sole string. And then we can just return all the values of this hash map. We don't have to return the string at all. We just have to return the values. That sounds like a good solution, doesn't it? But what will the time complexity of this be? It will be O of n, because I'm iterating over this entire list and then I'm sorting it. What am I sorting? These strings, right? So will the time complexity be O of n into n log n? No, it will be n into m log m. And this will be the case because m is the average size or average length of the string. Because I'm sorting the string, right? The characters inside of it. So it won't be n, because n here stands for the length of the list. M will be the average length of the string. Alright? If I just have to type it out, the sorted solution would be O of n into m log m, where n is the length of the list and m is the average size of the string. So this is the solution and it looks decent enough, not pretty bad. But the question remains, can we do better? Can we do better than this? And as a matter of fact, we can. And I say we can optimize the solution even further because I know the problem with this. So like, why do we get n into m log m? The problem isn't in the n. I have to traverse over the list. The problem is with m log m. Can we do the solution without sorting? And sorting becomes the bottleneck. It becomes the problem. So we need to eliminate sorting somehow. How can we do that? Well, instead of sorting, what we can do is basically just see the letters over here. We have E, A, T. So maybe we can create an array, right? We can create an array over here which keeps track of the count of all of these letters in a particular string. So for eat, we will have 26 different places in our array. So we'll have an array that will be like this. So it will be kind of like a compartment. Let me draw in a rectangle. There we go. And let's say there are 26 places over here. Why do I say 26? Because we know all of the characters are going to be small case. Why? Because it is mentioned in the constraints. We have our constraints which say S and T consist of lowercase English letters. So since they are lowercase English letters, I'm going to create 26 different places in this array. And this array is going to hold the count of how many letters there are in a particular string. So if we have EAT, what's going to happen is we are going to have 26 different places. First of all, let's say these are 26 different places. These aren't, but like just imagine these are 26 different places. So this part is going to contain A, the count of A. This is going to contain count of B. This is going to contain count of C. This is going to contain count of D, E, F, G, H, and so on. So what's going to happen here is I'm going to traverse over this list. I'm going to see this has a string of EAT. I'm going to loop through every character over here. So I'm going to have E first. I'm going to store the count of this E in this array. So initially the array is going to be 0. Then I'm going to see this E. So I'll just convert this to 1 because in this particular string, I've seen one E. Then I've seen one A. And let's say this was T over here. Okay. So I've seen one T. And I'm going to take this array and store it over here as the key of the hash map. And then I'm going to create a value, and the value is also going to contain the list of strings that have the same key. So eat has a count that looks like this. So I can just take this eat and put it inside of this list. Then we go towards T. So in T, this is again going to be 0. Let me remove it. So now I'm towards T. So I'll loop through every character in T. So I have T. So I'll just mark this again as 1. Then I'm going to have E. E is going to be 1. And A. A is going to be 1 again. So I have the same array as this one. So I'm just going to take this T and put it inside of the value of this key. Then I have tan. So what I'll do is go over this. I'll have every character here. So I have T1. A will be 1. and n will be 1. Let's say n is somewhere over here. So n is 1. So no such key exists in our hash map already. So I'm just going to create a new key. I'll store this over here. This array will be stored over here as the key, and the value will be tan. So I'll just store tan over here. Okay. Then I have ATE. So I'll again start from scratch. I'll remove this. And I have T as 1, A as 1, and N as 1. So now I'm at 8. So I'll have A as 1, T as 1, and E as 1. And it's similar to our key that already exists. So I'm just going to take this 8 and put it inside of the list again. So you see, we are grouping all the strings together in one array. The same will happen for NAT. When we have NAT, N will be 1, A will be 1, and T will be 1. So we'll just push this over here. And BAT will not have anything. We'll have to construct it from scratch. So B will be 1, A will be 1, and T will be 1. So BAT will have a new array of its own, and then BAT will be shifted over here. So BAT will come over here. So this has become a bit messy, but I hope you've understood the solution. What I'm doing is basically just iterating over this entire list. I'm iterating over all the characters in this list and storing them in an array. And how am I counting what characters are there? I'm just storing them according to the index. So if A is present, it will be stored at index 0. If B is present, B will be stored at index 1. C is present, C will be stored at index 2, and so on. And I can only use this approach because I have a constraint with me that S and T consist of lowercase English letters. Otherwise, it can be infinitely long list and you won't be able to know. But here we have a constraint that there are going to be only 26 letters. So now the big question arises, what's the time complexity of this? So the time complexity of this would be O of n, because I'm iterating over the entire list. Then I'm iterating over each of the characters, so it would be m, and then it would be multiplied with 26, because we have this array that is 26 characters long. So in the worst case, we have a string that is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So we'll have to fill this entire list with 1, 1, 1, 1, 1, 1, 1, and that would be 26 characters. And we know in the worst case scenario, it would be 26, right? So we have a time complexity of O of 26 in M. But we know that constants can be removed, so we can just remove this, and then the time complexity becomes O of n into m, where n is the length of the list and m is the average size of a string. So we have done this better. Instead of using m log m, we are using m now. So this is the optimal solution for it. I hope you've understood it. Let's code it out now. So initially we would need a hash map that would group anagrams together. So I can just create like a hash map. Again, you can name it more specifically. I'm just going to store it as a hash map so that everyone coding in different languages can follow along. Now I want to go through every character in this list, or every string in the list, sorry. So I'm going to have for string, and I cannot use str over here because str is a keyword in Python. I can just use string if I want, so it will give me access to a particular string, or I can just call it word. So for word in strings, I'm going to go through every word, and for every word I'm going to create a new array, right? Every word is going to start from scratch and is going to have a new array. So we can just have a count array which is equal to empty list, and we need to create 26 different sections in it. So I can just multiply this with 26. But just doing this much isn't enough, because initially I want the count to be stored as 0, right? If I have it over here, it should initially be 0 so that I can just increment it to 1. I'm not changing this to 1. I'm incrementing this by 1. So initially it is going to be 0, and we're going to create 26 different compartments in it. And then for every word, I want to get the character in that word. So I'll just do for character in word. I get access to each and every character. And then I update the count array based on this. So I'm going to create count. Now, how do I mark this A or E according to the position? I want the A to be 0. So the ASCII of A is 97. So to make the 0, I'll have to subtract it from 97 so that I get a 0. So if we have a B, then the ASCII of B is 98. So I can just subtract it from 97 so that I get a 1. So this solution is fine. I can just subtract it from 97. But where am I getting this 97 from? Well, it's just the ASCII of A, right? So I can just say count order. So this is how you get ASCII in Python. And those of you who don't understand ASCII, I'm talking about this ASCII. If you want, you can just paste it and you'll find something. So I'll just put order of character. So if I'm iterating over eat, I'll get access to E. And then what I want to do is subtract the ASCII of E with the ASCII of small a. So I'll just have minus order of small a, and then I just want to increment it by 1. So if you have EAT, I'll have E, so I'll just increment it by 1. So I'll have E minus A, and E in our case is going to be, well, C, D, E. So it's going to be 99, 100, 101, 101 minus 97, which will be 4. So it will go to the index 4 and store it. Okay? So this is our logic to create the key or to mark it at a particular index. So I've done this. Now I just need to store it in a hash map. So I can just do hash map at count, right? I can just do this, right? Well, let's see if it works. Hash map at count is equal to, what do I want to do here? Well, I have the key as this array and the value as a list which contains all of the string. So I basically need to add it to a list. But how do I tell my hash map that initially it is going to be a list? And for that, Python has a very cool trick. You can just use default dict. It comes from the collections library, I guess. So you can just do default dict and pass in a list over here. So what it will do is basically it will construct a hash map, and let me put a comment here. So it will create a hash map where there's going to be default lists present. So it's going to be present like this. Okay. So empty lists will be present. And because of that, I don't have to worry and check that, hey, a list is present or not. So I'll just do hash map at count. So I'll go to a particular count and append to it. So I'll just have append the word. And because of this, I don't have to set it to equal, right? Because when we append it to a list, it will return null, and that would mean hash map at count will become null. So yeah, we don't want to do this. If we just do this, it will just go to the particular hash map count. And I think we've gotten pretty messy over here. Let's just remove it. So we just have our hash map where this array is present as the key, and then we have the value. And in the value, I've told that, hey, this is going to be a default dict where the list is already going to be present. So an empty list is already present. And then what I'm doing is hash map at count. So it goes to the particular array and appends to the list. So if the list already contains something, it will append to the end of it. Otherwise, it will just add a new element in the list. The list already exists thanks to this little thing over here. So that was an edge case, and you might want to look after that. If you just put this and try it, well, you should try it and you'll better understand what's happening. Then I just want to return the value part of this entire list. I don't care about the keys, right? Because the key is the array, and I really don't care about the array. I only care about what's present in this entire values part. So I need to loop over all the values and get all those values in a mega list. So I'll have a mega list where all of the values will be present. So I'll just take the first value, put it in the mega list. I'll have the second value, I'll put it in the mega list, and the third value, which will be present in the mega list. So that's what I want to do. You can do it in any other programming language by looping through the hash map values and then making a mega list out of it and then returning it. In Python, what you can do is just return hash map dot values. With that, you'll have a list of all the values. And now if I run it, it doesn't work. And why doesn't it work? Well, because here's the thing about hash map. In hash map, you cannot store a list. If you try to store a list, it will give us an error because list is not hashable, and hash map basically hashes and creates a unique key, and arrays, lists cannot do that. So well, what can I do? Well, I can just convert it to a tuple then. If I just convert a list or an array into a tuple, it will work because tuples are hashable. And you see, it gets accepted, and when I submit, it works as well. So the time complexity for this would be O of n into m into 26, and we can ignore the constant, so the time complexity becomes O of n into m. And the space complexity for this would be O of n, because in the worst case scenario, all the strings are unique over here. None of the strings are anagrams of each other. So that means there will be n number of keys in the hash map. So there will be n number of elements in the hash map as well. So that's the time and space complexity. And this is it for this video. Thank you for watching. And I'll see you in the next video where we'll complete the remaining 4 medium problems of arrays and hashing.